Hello everyone, I welcome you to ICS Mahesh P. College Dharwad YouTube channel. Students, we are discussing the concept defects in the solids. Non-stoichiometric defects. These are the large number of inorganic solids found which contain the constituent particles in a non-stoichiometric ratio because of defects in the crystal lattice. These defects, because of presence of constituent particles in a non-stoichiometric ratio in the crystal structure, are called non-stoichiometric defects. Students, if the defect causes the uh, problem in the stoichiometry of the crystal, okay, or imbalance in the stoichiometric crystal, okay, it is called as non-stoichiometry. Imbalance may be in the ions, the number of ions, etc. Non-stoichiometric defect is mainly classified into two types: metal deficiency defect and metal excess defect. Let us discuss the first one, metal excess defect and ionic vacancies. Okay, students, look at this. Anionic vacancies. It is due to the absence of anion from the lattice site, leaving a hole. The anionic sites occupied by unpaired electrons are called F center. More the number of F centers, more will be the intensity of the color. Anionic sites occupied by electron to maintain electrical neutrality. Students, in this, what happens is you imagine NaCl crystal. In this diagram, you can understand a negative charge is for Cl, positive charge is for Na plus. Sorry, negative charge is for Cl minus, positive charge is for Na plus. Students, what happens? This defect is created due to the loss of one of the anion. You can see there is a box like structure in the diagram. That is the site where the removal of anion is taking place. Okay, how the anion is removed, that is the different part of discussion. So somehow the defect has occurred, leaving behind a vacancy due to the removal of anion. Okay, but since to maintain electrical neutrality, this vacant site is occupied by electron. Okay, students, as I told, okay, the removal of anion and the entry of electron, it's some different explanation. Okay, so see, for mainly this defect is due to the absence of anion, first thing. Second thing, the vacant site is occupied by an electron and hence that site is called as F center. More the number of F center, more the intensity of the color. Means more the number of removal of negatively charged ions, more will be the F centers and more will be the intensity of the, more will be the color of the solid. Okay. Example is NaCl and LiCl. Metal excess defect due to the presence of extra cations at interstitial site. Metal excess defect due to the presence of extra cation at interstitial site. See, zinc oxide is an example in which it is white in color at room temperature. On heating, it loses oxygen and it turns yellow. Okay, so why it turns yellow? Because it loses oxygen ion. Okay, and there will be more number of Zn plus 2. Okay, so and hence this type of defect can be called as metal excess defect. Metal deficiency defect are there. There are many solids which are difficult to prepare in the stoichiometric composition and contain less amount of metal as compared to the stoichiometric proportion. This defect is generally exhibited by transition metal. Charge is balanced by ion having higher positive charge. Example, FeO. Ferrous oxide is mostly found in the composition of 0.96% of iron and 100% of oxygen. Its composition may range from 0.93% of iron oxygen to 0.93% of iron to oxygen. Thank you, dear students. It's all about non-stoichiometric defects.